All right, trust you did well on your quiz. Quiz 28, students in here did a good job on the quiz. Let's take a look at a few more networks now. And instead of just getting equivalent resistance like we did on the quiz, I told them the next quiz is going to have everything. Equivalent resistance, total current, and then at individual resistances, how much current is going through, how much voltage is being used. All of that is going to be on the next quiz. So if you would, start by drawing a 9-volt battery. And to take a look, let's go ahead and practice with some sig figs here as well. Let's go with just 2 sig figs, though, because I'm lazy. Let's say 9.0 volts. And we'll have the current leave the battery and go initially through a single 1.0 ohm resistance. Current then passes through a 5.0 ohm resistance and passes through a 4.0 ohm resistance and back to the battery. I'm not a perfectionist or anything. There we go. However, we're going to add an additional pathway, an additional little loop, if you will, over here. Obviously, we'll draw it with hard right angles, though. Let's have first in the loop a 3.0 ohm resistance, and then have that travel to a 2.0 ohm resistance before the loop reconnects here. All right, so there's your network. If you would copy that onto your paper. As always, step 1, calculate the equivalent resistance. I'm going to have you do step 2 also on your own. Find the total current based on that equivalent resistance. I'm going to fill in those first 2 answers. Check your first answer once you've got it. Yes, sir.
Can you show me how you got 17.2 again?
Oh, that's a 1. That's not a 10. I thought that seemed awfully high. Sorry, my brain saw 10, 5, and 2.2. Let's go with that. That's going to change a lot of things. Okay. I was just seeing if you were paying attention, Michael. That is at 1.0. That is not a 10. That's obviously going to change the next answer then. I thought that seemed like an awful lot of resistance for a 9-volt battery to handle, but I was like, well, whatever. Do we like these numbers better?
Yes.
Okay. Kendall's good to go, Michael's good to go, and Audrey good to go. All right, it was just me that wasn't good to go. We're good to go now. Now let's set up the chart. Again, you're going to list out resistances, current passing through each resistor, and the IR drop at each resistor. Two of these rows are very easy to fill in. Fill in the first, or fill in the two rows that are the easy ones. All right, check your two rows that were easy. Did we get the two rows correct? All right, here we go. Parallel time. Solve, don't put anything on the chart. Just figure the 1, 2, 3 line items that need to be here. This we've already written here. We know the resistance. There's something else we know, and therefore there's something we can find. Get the 3 things that need to be here for the whole parallel set. Did we get that number? All right, so we're good on the whole parallel. We know how to solve the whole parallel. We got the resistance, we got the current, we got the voltage. One of those numbers carries to the branches. Which one is it, class?
Voltage.
It's the voltage, and that makes sense, right? If it were one of the other two, we wouldn't need to do the calculation, right? The point of the calculation was to get what we needed for the branches. So now, let's hit each branch. Get the 3 things for each branch that we need. Do we have each branch solved correctly? We know the 2.432 repeating volts carries. Obviously, this branch has only 4 ohms, so therefore the current, did we get 0.601081081 amps?
Yes, I didn't say it though.
Okay, so that's what you were doing. You were like, I got it, and then I realized, oops, it's not in the memory. All right, I actually haven't saved it yet either. But it's a repeating decimal, so I could type it a bunch of times if I felt like it. That said, it's still on my screen. Store 2. That one is not in the memory. That one I may have to type a few times. Okay, for the other branch, did we look at the branch as having 5 ohms of resistance and getting the same current voltage constant, 2.432 repeating volts? So then, did we get 0.486 repeating amps through that branch? Once 0.6081 amps has chosen this branch, it all goes across the resistance. Once 0.486 amps chooses this branch, it all goes across this resistance and this resistance, which allows us to fill in these three answers. Fill in those three answers now. Fill in the current through the parallels. Sorry, I didn't tell you to do this yet. All right, did we get those currents? I was going to the next step already. We're good on the currents. All right, now to get the IR drop, we just have to multiply. But remember, don't multiply by these numbers, multiply by the actual numbers, right? So where I've got this saved, I'm not going to do 0.61 times 4, but 0.6, let's see, recall 2, there we go, times the 4 to get how much voltage used up. 2.4 volts. And you say that would have been the same answer anyway. Well, sometimes it is, sometimes it isn't. I'm not going to use 0.48, not 0.49, I'm going to take 0.486, and multiply that times 3 to get. And that's the same thing I would have gotten anyway. I'm going to divide the 3 back out and then multiply the 2 to get what? And this is where it would have differed slightly. If you use the rounded answer, you're going to get a slightly off answer here for the voltage. 0.97 amps, or 0.97 volts rather. If you use the rounded, you'd be 0.98 volts. Now it's 100th of a volt off, not a huge difference, but again, we do want to use exact numbers. Doing it this way, step by step, are we starting to get a better idea of it? It's starting to. I got a little bit of uneasiness still on the face. Let's do one more together, and then tonight you'll do one for extra credit. All right. And we're going to start off with a measly little 6-volt battery this time. Right away, the current is going to split and go in through a 3.0 ohm resistor and a 1.0 ohm resistor. The current will then head down a split that features a 2.0 ohm resistance, a 4.0 ohm resistance, and a separate path with a 5.0 ohm resistance. As always, equivalent resistance first, then total current. I just read this really hard to read on the camera. All right, are we good on the first two numbers? Everybody's good. All right, set up your chart. Notice this time, there are no straightforward, easy ones. You see that? Nobody gets all 1.7 amps because everybody's sharing, everybody's splitting at some point. Does that make sense? All right, so here we go. Start by solving this whole parallel. The whole thing has 0.75 ohms. What else do we know about the whole thing, class? We also know the current is
1.7.
Yikes. And therefore, we can find the if you know R and I, voltage, right? We need the voltage of the whole thing. How much voltage gets used up here?
1.29.
I'm going to put that in memory too. What is that? And that number now transitions me from looking at the whole thing to looking at each branch. Looking at each branch. Good. I know that each one of these branches is going to get the 1.294 volts. Right? But what else do I know about this first branch? It has 3 ohms. I've already got it written there, and this branch has 1 ohm. All right, if I know V and I know R, I can find amperage, which is current I. If I know V and I know R, I can find I in amps. All right, I know why you said A there. All right, how do I find I? Divide what by what?
Your voltage by your ohms.
Good, V by R. So the 1.294 blah, blah, blah divided by the 3, how much current goes into this branch? 0.431 amps. How much, don't make this hard, how much current goes through this branch, class? 1.29 blah, blah, blah amps. Now, once the current goes into the branch, it's got to go across all the resistors in that branch. So each branch only has one resistor, but this resistor has to get 0.43 amps. And this resistor has to get 1.29 or 1.3 amps. And then since we know V, or since we know I and we know R, we can get IR drop. And not coincidentally, these numbers work out to be the same thing and a pretty familiar number to us. 1.294, blah, 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 rounded 1.3 volts. Here's the significance. Notice 1.294 volts goes into the branch. There's only one resistor there. It must use all that voltage. And this uses all that voltage also. So it makes sense that we get the 1.3 volts for both of them. Though my 3 looks awful because it's starting to write 2. All right, let's try that instead. All right, now we come to this other one. Now solve the next whole parallel. Stay with me. How much voltage gets used up at this whole parallel, class? Oh, you know what? I bet you used a rounded one. I got 4.705 blah, blah, blah volts. I'm going to put that in memory 3 and put down the blue chalk. Wow, that was bad. But if you didn't use a rounded number, I believe it comes out to the same thing roughly, 4.70, 4.7 volts. All right, if that's the voltage of the whole thing, class, that's the voltage through each branch. This branch and this branch, each 4.705 volts. What else do I know about the first branch? 6 ohms. What do I know about this branch? 5 ohms. And if I know voltage and I know resistance, I can find current. How much current goes into the first branch? 0.784 amps. How about the next branch? A little bit more, right? 0.941 amps, right? Because it's got a little bit less resistance, so it gets a little more current. All right, if you know the current through each branch, that's the current through each resistor or load. So both the 2 and the 4 have to get the 0.78 amps. The 5 ohms has to get the 0.94 amps. From there, we multiply. All right, we feel like we've got a pretty good grasp of it now. I feel like it's starting to come together for us. All right, here's your extra credit. We're going to have a 12-volt battery. Current's going to start off going through a 2-ohm resistor, down through a 6-ohm resistor, and back through a 5-ohm resistor to the battery. We're going to add an additional branch onto the side here, and this branch is going to have 3 separate resistances of 3 ohms, 1 ohm, and 4 ohms. Analyze this network for extra credit. We'll take a look at it at the start of our next lesson. All right. Once you got that copy down, you'll be dismissed. Have a wonderful rest of your day.